Hey everyone, welcome back to my channel. I'm Neil and today we're diving into quadratic functions, what they are and the best strategies to graph them clearly and confidently. So if you're ready to master parabolas and boost your math skills, let's get started. Please make sure to subscribe because I'll be covering more about this topic in upcoming videos. And if you found this video helpful, don't forget to give it a thumbs up and share it with your friends. Thank you so much if you are willing to do that for me. Okay, today I'm going to talk about axis intercepts. We have two types of intercepts, x-intercepts and y-intercepts. What is x-intercepts? An x-intercept is a value of x, where the graph, you can see we have this graph, where the graph meets the x-axis. So we have these 2 points, which are x-intercepts. And how can I find x-intercepts? X-intercepts are found by letting y be 0 in the equation of the curve. So you just need to put the equation equals 0 and solve for x to find x-intercepts of any graph like this. And another intercept that I have is y-intercept. And this is here. And a y-intercept is a value of y, where the graph meets the y-axis. And y-intercepts are found by letting x be 0 in the equation of the curve. Now I'm going to show you how you can find x and y intercepts in this example. This is the quadratic function and I'm going to find x and y intercept. As I said before, for finding x intercepts, we should let y be 0. So y is 0 and substitute 0 in this equation. You can use different ways to solve for x. I'm going to use sum and product rule because -4 is the product of two numbers and +3 is the sum. 4 times 1 is 4, and because the sum is a positive number, so the bigger number is positive. So +4 and -1. So 0 equals x minus 1 times x plus 4. So I factorize this equation to this form. And according to null rule, when we have two parentheses multiply by each other and equals 0, each of them is 0. So x is +1 and x is -4. So we have two solutions and two x-intercepts. Two points lie on x-axis. And now for finding y-intercept, x should be 0. So if x is 0, so y equals to 0 squared plus 3 times 0 minus 4. So y is 0, 0. is negative 4. And this is the y-intercept. The point lies on y-axis. Now you can see that y is negative 4 is y-intercept, which is here, negative 4, the constant in this equation. So there is a trick. If you are going to find y-intercept in this form of equation, you just need to find c. A, B, C are constant in any equation. So c is negative 4. So in equation in this form, ax squared plus bx plus c, c is y-intercept. And you don't need to calculate it. Okay. So far, so good. As another example, y equals negative x squared plus 2x plus 3, and I'm going to find y-intercept directly. Y-intercept is positive 3. Okay, and how about x-intercept? So let y be 0. 0 equals negative x squared plus 2x plus 3, and solve for x. I'm going to use factorization. So let me multiply both sides of the equation by negative 1 or negative sign. So x squared minus 2x minus 3 is 0. According to sum and product rule, we can factorize it x minus 3 times x plus 1, because the product is negative 3 and the sum of them is negative 2. So x minus 3 is 0, x is positive 3, and x plus 1 is 0, x is negative 1. X-intercepts of this graph. Okay. And now I'm going to talk about quadratic graphs and another strategy to sketch a parabola. Consider y equals x minus 2 times x minus 4. This graph has two x-intercepts, because if you equal this to 0, the first one is positive 2 and the second one is positive 4. These are two x-intercepts of this parabola. But I need more points for graphing this parabola. All quadratic graphs are symmetric about a vertical line throughout the vertex, as I said before. This axis of symmetry must be midway between the x-intercepts. For example, if you have this parabola, this is the axis of symmetry, and this is the midway between these two x-intercepts. And how can we find it? We just need to find the average of these two x-intercepts. So the average of 2 and 4, sum of them over 2, 6 over 2 is 3. So x equals 3 is the axis of symmetry, the equation of that. And you know that this is the x-coordinate of the vertex. So for vertex, we have 3, and now we need to find y, the y-coordinate of the vertex. So we just need to substitute 3 into the equation. Y is 3 minus 2 times 3 minus 4, which gives us 1 times negative 1, and y is negative 1. put this here. So we found the vertex. So we have two x-intercepts and the vertex, and the last thing that we need is y-intercept. So this is not in general form. Y is ax squared plus bx plus c. To find c as y-intercept, so we need to let x be 0 to find y. So if x is 0, y is 0 minus 2, 0 minus 4, which is positive 8. So this is y-intercept. The only thing that we need is to plot all of these points and draw a graph passing through all of these points. Okay, x-intercepts are 2 and 4, 2 and 4. So we have these 2 points lie on x-axis, and after that we have vertex 3 and negative 1, 3 and negative 1, which is here, and the y-intercept, a point lie on y-axis, is 8. 1, 2, 3, 4, 5, 6, 7, and 8. And here. Okay, and I'm gonna draw a graph. We can continue this side. Okay, and this is our graph. Y is x minus 2 times x minus 4. And you can see that the axis of symmetry is here. X is 3. Okay. So in this strategy, we need 2 x-intercepts, we need the vertex and y-intercept to sketch our graph. So this strategy is really helpful for us to graph a parabola accurately. Okay, as another example, y is negative x plus 1 times x minus 3. So we need 2 x-intercepts. So if x plus 1 is 0, x is negative 1. And x minus 3 is 0, x is positive 3, are 2 x-intercepts. And then we need the vertex, the x-coordinate of the vertex, which is the average of negative 1 and positive 3. 2 over 2 is 1. So x equals 1 is the axis of symmetry. And x-coordinate of the vertex, 1. And how about y? Substitute 1 into the equation. 1 plus 1 times 1 minus 3. So y is 2 times negative 2, negative 4 times negative is positive 4. So far, so good. And how about y-intercept? So if x is 0, y is negative 0 plus 1 times 0 minus 3. So y is negative 1, negative 3, positive 3, the y-intercept. And now negative 1 and positive 3, 1, 2, 3, these 2 x-intercepts. Y-intercept is positive 3, 1, 2, 3, and vertex is 1 and 4 here. So this is y equals to negative x plus 1 times x minus 3. So far so good. Now I'm going to talk about maximum and minimum values of quadratics. We have already seen that the graphs of quadratic functions may open upwards or downwards, and it depends on the a, which is the coefficient of x squared. For example, if y is x minus 2 squared plus 3, a is 1 here, the coefficient of x squared. And because a is a positive value, so this graph opens upwards. Something like that. So if we found vertex, and vertex is here positive 2 and positive 3. Okay, and the vertex is 2 and 3, and at this point the function is a minimum because this point is the lowest point in this function. And as another example, y equals negative x minus 3 squared plus 5. So you can see that a here is a negative number. So this graph opens downwards. And the vertex is positive 3 and positive 4. So the graph is something like that. Positive 3 and positive 4 is the vertex. And this is the highest point on this graph. So because this opens downwards. So at this point, the function is a maximum. Okay. Find the maximum or minimum value of x. So y is x squared minus 3x plus 1. And for this equation, I'm going to use completing the square to find the vertex of that. Okay. In this method, we should find b. b is the coefficient of x. Divide this number by 2, which gives us negative 3 halves, and then find the square of that, which is 9/4, and we should add and subtract this number. Add and subtract because we want to maintain the balance of this equation. So y is x squared minus 3x plus 9/4 plus 1 and minus 9/4. And for these three terms, we can write x minus 3 halves squared. This is a perfect square identity. And for the left, 1 minus 9/4, the answer is negative 5/4. So in this form, you know that we have the general form y is x minus h squared plus 4. And in this case, vertex is h and k. So here vertex is positive 3 halves and negative 5 fourths. This is the vertex. And because A is a positive number, so this graph open upwards. Okay, something like that. This is the vertex. So we have minimum value of y. So we can write this, the minimum value of y is negative 5 fourths, where x is 3 halves. Okay, I hope you enjoy in this video. See you in the next one. Bye bye.